In this video, we're going to look at bond energies. Bond energy, or dissociation energy, is the energy required to break 1 mole of bonds in the gas phase. If we look at hydrogen chloride in the gas phase, if we disassociated hydrogen chloride into hydrogen and chlorine, we get an enthalpy of plus 431 kilojoules. We can also express this, instead of delta H, as DH bond Cl, indicating that we're going to disassociate a hydrogen-chlorine bond. We can use these dissociation energies, or bond energies, to calculate delta H for reactions. It's not going to be exact. It's always an estimate. The reason is that dissociation energies are 1 mole of bonds in the gas phase. This is not how we normally do reactions. Reactions are often in solutions and not in the gas phase. But this can give us a ballpark estimate, often very close to the actual estimate, or the actual enthalpy. Let's look at the formula. Delta H is about equal to the sum of the dissociation energies of the broken bonds minus the sums of the dissociation energies for the formed bonds. Dissociation energies are always positive. Let's look at a question. Use bond enthalpies to estimate the enthalpy of reaction for the combustion of methane. CH4 in the gas phase plus 2 moles of oxygen in the gas phase produce carbon dioxide in the gas phase plus 2 moles of water in the liquid phase. To do this, what we need to think about is what bonds are being broken and which bonds are being formed. To know which bonds are being broken and which ones are being formed, we're going to have to look at the Lewis structures. So let's draw the Lewis structures for these. We see that carbon has 4 bonds to hydrogen. Oxygen is actually a double bond. Carbon dioxide is a carbon double bond oxygen and another carbon double bond oxygen. And then for water, we have single bonds to the hydrogens. Now what we want to do is add up on each side those that are being broken. So on the reactant side, we're going to have 4 CH bonds that are going to be broken and 2 oxygen double bond oxygens. On the product side, now we're going to be forming react bonds. So if we form bonds, we have 2 C double bond O bonds being formed, and we'll have 4 H oxygen bonds being formed. We can now look up the values of each of these. So dissociation energy of a carbon single bond hydrogen will be 414 kilojoules per mole. The dissociation for oxygen double bond oxygen, and note it's a double bond, so therefore you need to make sure you get the right value, is 498.7 kilojoules per mole. A C double bond oxygen dissociation energy, again, make sure that you're looking at the right number of bonds between the carbon and oxygen, is 799 kilojoules per mole. And dissociation of a hydrogen-oxygen single bond, we see 460 kilojoules per mole. We'll take these and put them into that formula, bonds broken minus the sum of the bonds formed, and we'll come up with our equation. 4 times 414 kilojoules per mole plus 2 times 498.7 kilojoules per mole for the bonds broken, minus 2 times 799 kilojoules per mole plus 4 times 460 kilojoules per mole for the bonds formed. Do the math, and we get an estimate for our enthalpy of minus 785 kilojoules per mole. When doing bond energy calculations, always remember it's an estimate. Always make sure that you look at the Lewis structures so you'll know whether it's going to be single bonds, double bonds, or even triple bonds, and use the correct quantities. Practice with these, get confident so you can be successful in the course.